Hello everyone. Today's video is about coagulation of blood. It is a new video in my channel. If this video is helpful to you, please like, comment and subscribe my channel and also share it with your friends because all of these are inspiring me to make more and more video. So let's start. First, what is the definition of coagulation of blood? Coagulation of blood or blood coagulation is defined as the process when blood loses its fluidity and become a jelly-like mass few minutes after a shed out or blood collection. So when our blood vessel injured due to any internal or external factor, in this time particularly in these specific places, blood loses its fluidity and become a jelly-like mass and form blood coagulation. So it is a mainly process of stoppage of bleeding and their platelets and protein in plasma work together to stop bleeding by forming a clot over the injury. So platelet and protein or enzyme that is made up of protein. In the plasma, they work together to stop bleeding by forming a blood clot. Then what is hemostasis? It is an additional point I add and I think it is helpful for the better understanding of this topic. So what is the definition of hemostasis? Hemostasis is defined as the process of stoppage of bleeding. So hemostasis is a process that explains the procedure of stoppage of bleeding. And it is occurs through the three stages. First vasoconstriction, second platelet plaque formation, it form temporary blockage, and then coagulation of blood. It form permanent blockage. Then factor involves in blood clotting. Coagulation of blood occurs through a series of reaction due to the activation of group of substance. So the substance that is necessary for the clotting are called the clotting factor. So coagulation of blood occurs through a series of reaction of clotting factors. There is 13 clotting factors are identified. This is a number and name of the clotting factors. Factors 1 fibrinogen, factor 2 prothrombin, factor 3 thromboplastin, factor 4 calcium, factor 5 labile factor, factor 6 presence has not been proved. Its presence is not proved till now. Factor 7 stable factor, factor 8 antihemophilic factor or antihemophilic globulin, factor 9 Christmas factor, factor 10 Stewart power factor, factor 11 plasma thromboplastin antecedent, factor 12 Hegman factor, factor 13 fibrin stabilizing factor. All of these clotting factors are named after the scientists who discovered or as per their activity. Only the factor 10 or Christmas factor was named after the patient in whom it was discovered. Then I will discuss about clotting mechanism. First of all, what is enzyme cascade theory? The classic theory of coagulation was discovered by Paul Mertes in 1905. Then Davy, Ratnov and McFarlane described the concept of blood coagulation in details in 1960. So the classic theory of blood coagulation was discovered first Paul Mertes in 1905. Then the detailed concept of blood coagulation was described by three scientists Davy, Ratnov and McFarlane in 1960. So enzyme cascade theory. First, enzyme. Enzyme is a protein that helps to speed up any chemical reaction in our body. Then, cascade. The term cascade refers to the process that occurs through a series of steps, each step initiating the next until the final step is reached out. Most of the clotting factors are enzymed, which is made up of protein. Basically, most of the enzymes are made up of protein. So, all the clotting factors are present in inactive proenzyme forms. But due to the inverse clot formation, these proenzymes are converted into the enzyme that is the active forms and it carried out by a series of the proenzyme-enzyme conversion reaction. First one is converted into the active enzyme that activates the second one, which activates the third one. This continues till final active enzyme, thrombin, is formed. So this enzyme cascade theory basically based on the series of proenzyme-enzyme conversion reaction. First one is converted into the active forms that activates the second one, which activates the third one, and this process is continuous till final active enzyme thrombin is formed. So enzyme cascade theory explains how various reactions involved in conversion of proenzyme to active enzyme take place in form of cascade. So it explains how various reactions are occurs and it form cascade. So inactive proenzyme to enzyme conversion method are described in enzyme cascade theory. Then the stages of blood clotting. Clotting occurs in three stages. First, formation of prothrombin activators. Second, conversion of prothrombin into thrombin. Third, conversion of fibrinogen into fibrin. So in the time of the blood clotting, first prothrombin activator forms, then it is converted into the thrombin and this thrombin helps to convert the fibrinogen into fibrin. You see in this chart that though intrinsic and extrinsic pathway, prothrombin activators are formed that is converted into the prothrombin to thrombin, and this thrombin helps to convert fibrinogen into fibrinogen active forms. Then it forms tight blood clot. So the way how prothrombin forms, and then how thrombin forms, and finally how blood clot formed. In this video I will discuss about the process in details. So the first stages is formation of prothrombin activators. It is the early stage of blood clotting. Formation of prothrombin occurs through the two pathway. First intrinsic pathway and the second is extrinsic pathway. So through the intrinsic and extrinsic pathway, prothrombin activators are formed. First, intrinsic pathway for the formation of prothrombin activators. It is initiated by the platelets which are present within the blood. So the intrinsic pathway is initiated by the platelet. First, during injury the blood vessel is ruptured, endothelium is damaged and collagen beneath the endothelium is exposed. So due to the rupture of blood vessel, endothelium is damaged and the collagen that is present beneath the endothelium is exposed. So when factor 12, the name of the factor 12 is Hegman factor, comes in contact with the collagen, it is converted into activated factor 12 in the presence of kallikrein and high molecular weight kinogen. It is also called HMW kinogen. H for high, M for molecular and W for weight. Then the activated factor 12 converts factor 11 into activated factor 11 in the presence of HMW kinogen. The activated factor 11 activates the factor 9 in the presence of the factor 4. The name of the factor 4 is calcium. Activated factor 9 activates the factor 10 in the presence of the factor 8 and calcium, which is the factor 4. This theory part also can explain with a flowchart. So first of all, due to the rupture of blood vessel, our endothelial become damaged. So the collagen which is present beneath the endothelium is exposed. So in the presence of kallikrein and HMW kinogen, inactive factor 12 is converted into the active factor 12. Here A means active. Then in the presence of HMW kinogen, active factor 12 converted inactive factor 11 into the active factor 11. Then in the presence of the calcium, active factor 11 converted inactive factor 9 into the active factor 9. Then in the last step, factor 8 and the calcium factor, which is also a factor 4, active factor 9 helps to activate inactive factor 10 into the active factor 10, which is the important for the activation of prothrombin. So with the 1, 2, 3, 4, 5, 6, to the 6th step, activated factor 10 are formed. Then 7, when platelets comes in contact with collagen of the damaged blood vessel, it get activated and release phospholipids. Then the activated factor 10 react with the platelet phospholipid and the factor 5 to form prothrombin activator in the presence of calcium ion. Then factor 5 is also activated by the positive feedback effect of thrombin. You see in this flowchart that due to the damage of blood vessel, platelet comes in contact with the collagen and then it is released phospholipid, which is react with the activated factor 10 and factor 5 and form prothrombin activators, and their calcium ion is also helps in this conversion. So in the intrinsic pathway, first due to the damage of blood vessel, endothelial is also damaged and the collagen which is present beneath the endothelium is become exposed. So in this time, in the presence of the kallikrein and HMW kinogen, inactive factor 12 is converted into the active factor 12, and also in the presence of the HMW kinogen, active factor 12 helps to convert inactive factor 11 into the active factor 11. Then in the presence of the calcium, active factor 11 helps to convert inactive factor 9 into the active factor 9. Then the active factor 9 helps to convert inactive factor 10 into the active factor 10 in the presence of the factor 8 and the calcium ion, which is also called the factor 4. And then when the platelets came in contact with the collagen, it helps to release phospholipid, and this phospholipid react with the activated factor 10 and activated factor 5 and form prothrombin activator. Then extrinsic pathway for the formation of prothrombin activators. It is initiated by the tissue thromboplastin, which is formed by the injured tissue. So the intrinsic pathway is initiated by the platelet and the extrinsic pathway is initiated by the tissue thromboplastin, which is formed from the injured tissue. So first, during the injury, the blood vessel is ruptured and start release tissue thromboplastin, which is a factor 3. Then the thromboplastin contains protein, phospholipid and glycolipid, which act as a proteolytic enzyme. So this glycoprotein and the phospholipid component of the thromboplastin converts factor 10 into the activated factor 10 in the presence of the factor 7. Then the activated factor 10 reacts with the factor 5 and the phospholipid component of the tissue thromboplastin to form prothrombin activator in the presence of the calcium ion. You see in this flowchart that due to the rupture of blood vessel, our body tissue start to release thromboplastin, which is then converted into the glycoprotein and phospholipid. And this thromboplastin contains protein, phospholipid, glycolipid, phospholipid and protein which act as a proteolytic enzyme. So this glycolipid and phospholipid of the tissue thromboplastin helps to convert inactive factor 10 into the active factor 10 in the presence of the factor 7, and in the presence of the calcium and factor 5 it is converted into the prothrombin activators. So in this slide I merge intrinsic and extrinsic pathway of the blood coagulation. So due to the rupture of blood vessel, our endothelial become damaged and the collagen which is present beneath the endothelium is become exposed. So in the presence of the kallikrein and HMW kinogen, inactive factor 12 is converted into the active factor 12. Then it helps to convert inactive factor 11 into the active factor 11, which activate the factor 9, and this activated factor 9 helps to convert inactive factor 10 into the active factor 10 in the presence of the calcium and factor 8. And due to the exposure of the collagen, our platelets start to release a phospholipid which is react with the activated factor 10 and activated factor 5 and form prothrombin activators. And in the intrinsic pathway, when our tissue become ruptured, it start to release thromboplastin, and in the thromboplastin protein, glycolipid, phospholipid are present. This glycolipid and phospholipid helps to the activation of factor 10, and this activated factor 10 in the presence of the calcium and factor 5 and also in the presence of the glycoprotein and the phospholipid, it is converted into the prothrombin activators. So both intrinsic and extrinsic pathway, finally prothrombin activator is formed. Then the stage 2, conversion of prothrombin into thrombin. It is the most important step because once the thrombin is formed, it is definitely leads blood clot formation. So in the first step, prothrombin forms, and in the next step, prothrombin is converted into the thrombin. And why this step is important? Because once the thrombin is formed, it is definitely leads clot formation. So due to the clot formation, we must need thrombin. In this step, prothrombin activators converts prothrombin into thrombin in the presence of the calcium ion, which is a factor 4, and the prothrombin activator, which is formed from intrinsic and extrinsic pathway that I already discussed. Once formed thrombin initiates the formation of more thrombin molecules, and the initially formed thrombin activates the factor 5, which accelerates the formation of both intrinsic and extrinsic prothrombin activators and converts prothrombin into thrombin. This mechanism of thrombin is also called positive feedback mechanism. So in this step, prothrombin activators helps to convert prothrombin into thrombin in the presence of the calcium, and this initially formed thrombin continuous activates the factor 4 because it helps to accelerate the both of the formation of intrinsic and extrinsic prothrombin formation. This initially formed thrombin continuous activate factor 5 because it helps to accelerate the formation of both extrinsic and intrinsic prothrombin activators, which helps to convert prothrombin into thrombin. And this mechanism is also called the positive feedback mechanism because the thrombin activates the factor 5, which is activate the prothrombin activators, and the prothrombin activators which helps to convert prothrombin to thrombin. So it helps to the formation of more and more thrombin. Then third stage, it is the final stage of blood clotting, conversion of fibrinogen to fibrin. The final stage of blood clotting is the conversion of fibrinogen into fibrin by the thrombin. First, thrombin converts inactive fibrinogen into active fibrinogen. The activated fibrinogen is also called fibrin monomer because in the time of the activation, it lost two pairs of polypeptide from each fibrinogen molecules and form fibrin monomer. And then step 2, fibrin monomer polymerize with the other monomer molecules and form loosely arranged strands of fibrin. Then in the presence of calcium ion, these loose strands are transferred into the dense and tight fibrin threads by the fibrin stabilizing factor, which is also called the factor 13. Then all tight fibrin threads are aggregated to form meshwork of stable clot. You see in this flowchart that the thrombin, which is formed in the second step, it helps to convert inactive fibrinogen into the active fibrinogen. Then they are polymerized and form loose strand of fibrin. And then in the presence of the factor 13, which is also called fibrin stabilizing factor, and in the presence of calcium ion, which is a factor 4, it helps to the form fibrin tight blood clot. So finally blood clotting happen. So this is the last slide where I merge stage 1, stage 2 and stage 3. First the formation of prothrombin activators, then the formation of thrombin, and the finally blood clot happen. Again I will discuss it briefly. First, though the intrinsic and extrinsic pathway prothrombin activators are formed. So in the intrinsic pathway, due to the rupture of blood vessel, endothelium is damaged, so the collagen which is present beneath the endothelium is become exposed. So in this time, in the presence of the kallikrein and HMW kinogen, inactive factor 12 is converted into the active factor 12, which helps to the activation of factor 11, and then the factor 11 which helps to the activation of factor 9, and this factor 9 helps to the activation of inactive factor 10 to the active factor 10 in the presence of calcium and factor 8. And due to the exposure of the collagen, our platelets start to release phospholipid, which is react with the activated factor 10 and activated factor 5 and form prothrombin. And in the extrinsic pathway, due to the damage of tissue, our tissue start to release thromboplastin, and this thromboplastin are also contains protein, glycolipid, phospholipid, which is a type of proteolytic enzyme. It helps to the conversion of inactive factor 10 into the active factor 10, and in the presence of calcium factor 5 and also the presence of the thromboplastin, glycolipid, phospholipid, it is converted into the prothrombin activators. So in the first stage, both intrinsic and extrinsic pathway, our prothrombin activators are formed. Then this prothrombin activators help to conversion of prothrombin into thrombin. And this initially formed thrombin also helps to the activation of factor 5, because this activated factor 5 helps to the formation of more and more prothrombin activators, which helps to the conversion of prothrombin into thrombin. And this mechanism is called positive feedback mechanism. Then the thrombin helps to conversion of inactive fibrinogen into the active fibrinogen, which become polymerized and form loose strand of fibrin. This loose strand of fibrin in the presence of the factor 13, which is also called the fibrin stabilizing factor, and the factor 4, which is also called the calcium, form fibrin tight blood clot and complete our blood coagulation. So finally the process of blood coagulation are completed. So I try to discuss this topic in details. So if this video is helpful to you, please like, comment and subscribe my channel, and also share it with your friends. Thank you everyone.